Hello, you absolute legends, and welcome back to Creating. In this video, we're going to see how you can make these beautiful looking shots that look 3D printed in Blender. Introducing Stitcher. This add-on that I made allows you to import G-code files into Blender and to render them. We would discuss the design process, the usage, the caveats, where to get it, and also the direction for its future. But before all of that, for those of you who do not know what G-code is, it's the language a 3D printer understands. When you slice a model for it to be printed on your 3D printer, the slicer produces a G-code file. I have already made a very thorough explainer about G-code with a ton of detailed animations. You can click on the I button if you'd like to check it out. Also, by the way, in that video I hid $20 and nobody has claimed them yet. So what are you waiting for? Now, this plugin started with an idea of creating 3D printer time lapses in Blender, because even though I have a good time lapse setup, I don't like to use it. I have to light it, set up the camera, make sure nobody bumps into it, and no matter how hard I try, the time lapse always creates unwanted artifacts in my prints. So I thought, yeah, why not? So I actually started by writing a script that slices the actual model. But I soon realized that it's going to be a lot of work. So I decided to use something that other people have already created. Slicers. Somebody has already done the work for me and done it much better than I can ever do. So why not just use it then, right? I went with PrusaSlicer. Yes, currently only PrusaSlicer is supported, although Cura support is on its way. We'll discuss this at the end of the video as well, but throw a like and a comment about Cura if you'd like to see it come sooner. So, when you slice your model with PrusaSlicer, it produces a G-code file. For the design process, you'd need to understand what information this G-code file gives me and what do I actually do with this information. So, first and foremost, the G-code file tells me where my extruder moves to and how much filament it actually extrudes. But more importantly, most slicers, including PrusaSlicer and Cura, include hints as to what the width and height of a particular extrusion should be. To understand how I leverage this, let's now move to Blender. In Blender, we can have some Bezier curves. And if you're hearing any fan noise in the background, that's the sound of my laptop dying because it cannot handle all the heavy software that I'm running on it. Anyway, back to the point. So in Blender, we have Bezier curves. We can define another curve and use it as an extrusion profile for this curve. That would give our curve geometry. So something like this. I select this curve. I go to the geometry section, object, and I select this other circle. And we have some geometry on our original curve. I can even decide how much of the curve I actually want to cover. So from here, I can vary the start and end of this curve. This is actually the basis of the whole add-on. But before we go any further, I'd like to tell you that I work hard on these videos and I put my heart and soul into them. I do everything from the 3D printing, the programming, the animations, and even the music myself. So if you enjoy my content, you can consider supporting me on Patreon. But if you're looking for another way to support me, just throw in a like and more importantly a comment for the algorithm and subscribe to not miss out future content. And now back to more important stuff. I create these curves using the G1 and G2 commands in the G-code, and then I create these extrusion profiles based on the width and height hints. To create these extrusion profiles, I needed a very clear understanding of how Bezier curves work, and I have already made another video in that regard. You can find it on here, just click on the I button. Basically, for anyone who is interested, this is how these extrusion profiles are made. I just create a closed Bezier curve with 4 vertices. I manage the handles in such a way that it approximates the shape of deposited filament. This is the width, this is the height. You can actually even vary the roundness of this filament profile, this extrusion profile, but I have not exposed this option to the end user just yet, maybe in the future. And that's it. Honestly, this was not the hard part at all. I literally finished a basic version of this in just 2 days. Sure, polishing it took longer. These curves don't have rounded edges, so I had to figure out a way to tackle that. There was no way to toggle features, so that had to change. I had to add imperfections as well. All of it though, it was challenging but still a breeze, not frustrating. The real hurdle was the UI and the Blender API. Oh my god. It took me 3-4 days just to present a status to the end user. There is just no easy way to do it. If you did not specifically design your script knowing the fact that presenting a status is not plug and play, your script is just not going to work. I personally wrestled with the idea of releasing the script without any status reporting, and I almost did. But I somehow figured out a way to do it in a pinch. There are some other design decisions throughout the API that threw me off my game many times. It's just a bit different than any other sort of programming that I'm used to. But anyway, this was all about the design process. Now let's get to the tutorial and the caveats. So now let's move on to the tutorial. Once you have installed the plugin, it would appear here on the sidebar. The import process is fairly straightforward. You just need to make sure that you have a G-code that has been sliced with PrusaSlicer. The G-code is going to appear here. It's going to use the x-axis as the x-axis of the printer and the y-axis as the y-axis of the printer. I have included some assets with the plugin that would make it easier for you to create shots by giving you some standard lighting and a standard set. So if you just click on load assets, it would load a camera, few lights, and some backdrop and a plate. So the actual model is going to appear here, right in this section. So let's just click here, find our file. Make sure relative path is unchecked, otherwise it won't work. It needs the absolute path. Just accept. Once you click on load G-code, it would start showing you a model as it loads the G-code. So let's just click on load G-code. Here it would show you how many layers have been done, and here you'd see the actual model. Try not to move a lot of things in the scene, or it would become very difficult for Blender to process everything at the same time, and it might freeze. One important thing to note here is that this object only has 160 layers. As the number of layers increases, the processing time goes up exponentially. I have not yet been able to figure out why that is. Somewhere around 400 to 500 layers works beautifully, but more than that becomes a problem to import and sometimes even to render. So that is a caveat that you should keep in your mind. So this is our model that has now been imported. Let's take a look at few of the filters. In the filters, you can show or hide different parts of the object. I would recommend that most of the times you keep the infill invisible because that would give you better performance in Blender. You can hide most of the other things as well most of the times. If you uncheck viewport only, the changes you make here would also show up in your render. Otherwise, everything would show up in your render and these changes are only for the viewport. I would also recommend that you turn off endpoints most of the times because endpoints are these small circular disks. So if you see here, the endpoints are rounded. If I uncheck endpoints, it would hide these and it would give you a performance boost as well. And you don't need to see them in your viewport. So most of the times just keep endpoints as off, just keep internal infill as off. Now let's take a look at a few of the other options. Most important is probably this layer index option. So it's by default set to 5000, but we only have 160 layers. So if I set it to 100, it would hide all the layers above layer 100. So there you go. Let's set it to something lower. Let's say 60 or even lower. Let's go 30. So you can't see the infill right now because we have turned it off. But if I turn the infill on, you can see the infill as well. Let's take a look at what this seam distance is. You can basically decide how big or small you want your seams to be. By default, it's set to 0.2. You can lower it to 0. If you turn the endpoints on, it would appear as if there is no seam. In the render, you'd see no seams. But you can also increase it considerably. If you want the seams to be bigger, you can do 0.4 and the seams would look bigger. There is also a way to randomize this. We'd see that in just a minute. So in this section, there is width offset, height offset, precision, and seam aberrations. These 4 things, you have to set them before you import the G-code. We'll take a look at what these are as well. So for width offset, this applies to the extrusion profile. If you give it a positive or a negative width offset, the width of your extrusion would increase or decrease by that margin. Same goes for height. Precision is how precise you want your width or height to be. I would recommend you just leave it at 4 because that would give you an accurate enough approximation and still save processing power. For seam aberrations. So seam aberrations is how much you want your seams to vary. So here you set how big your seams should be, and using seam aberrations you can actually randomize that. So this is the minimum distance your seams would be, 0.4 would be the minimum, but I can randomize it in such a way so probability decides how many of these endpoints would be affected. If I do 100, so 100% of the endpoints would be affected. If I do 50, only 50% of the endpoints would be affected. Amount would decide how much is the maximum distance that your seams can vary. So let's take a look at it real quick. I'd have to delete the things I have already imported for me to be able to show you this. So let's go and re-import the model, but this time with some seam aberrations. So let's give it an amount of 0.3. I'm giving it a bigger amount on purpose so that we are able to see, and a probability of 60. So that means that 60% of the endpoints would be varied from their seam distance from 0.2. On second thought, the processing time that goes up exponentially with bigger objects with a lot of layers might not be because of the code, it might just be because my laptop thermal throttles a lot. That would require some amount of testing, which I would have to do on my computer or on some other computers. So that's why I'm releasing this in beta. So all of you can tell me your experiences. Let's just go ahead and take a look at the seams now. You can clearly see here that some aberrations have been added. The seams are not as clean as they were, not as uniform as they were. Yeah. Now for the last option, that is the extruder error. I'm going to turn off a few things to make things easier for myself. So in extruder error, you can decide some probability, let's say 10%, and then you can make selection. It's only going to select the external perimeter, and it's only going to select 10% of the external perimeters. So if there are 100 external perimeters, it would only take 10 out of them. So let's make a selection. There you can see the selected layers. If you're not happy with what has been chosen, you can make a selection again. Or you can also manually just select any number of external perimeters you want to select. You can select this one, and let's say this one. Now you just decide the density of your errors and click apply errors. The density you can change it after the fact as well, so you don't have to worry a lot. Just click apply errors. And ta-da! You would see some errors have been applied. You can increase or decrease the density after the fact. So these are more errors, and then you can have slightly less errors. That's up to you, the look that you want. The only feature I haven't explained is this Meshify feature, which is very experimental and slow right now, so I don't recommend you use it. I would discuss it later when I give you a few tips. But for now, these are all the features of the plugin. And now let's move on to a few caveats. The biggest caveat that some of you might already have realized is that all this is real geometry. That means a lot of number crunching and a lot of computing power. Before you get disheartened though, let me show you my workstation. This is it. It's my mid 2015 MacBook Pro 15-inch. It does have a GPU, but Blender does not support it. So for all intents and purposes, it doesn't have one. All the development happened on this device. All the scene setting and animations happened on this device. Some of the images were rendered on this device. The videos though, the time lapses, were not rendered on this machine. I did the rendering on a rented machine on vast.ai. All I'm trying to tell you here is that the add-on works on my 7-year-old machine. If you have anything newer that isn't a potato, you're fine. A lot of my design decisions were based purely on what would work on my personal potato, so you don't have to worry a lot. If you want to render images, chances are your computer can do it. Might take 10-15 minutes, but it'd work. If you want to render time lapses though, I think it'd require computers not everybody has, RTX 3080s and the like. But if you do have one, that's my Patreon. What the hell are you even waiting for? Another caveat is the long processing time for objects that have too many layers. I've seen that between 400 to 500 layers is what works smoothly on my computer. I have done bigger renders. This Sanjay Mortimer time-lapse was 669 layers and the Adelinda time-lapse was above 700. But importing them took a lot of time. More than 30 minutes for the Sanjay Mortimer burst and even longer for the Adelinda time-lapse. If you're okay with that, that's alright. I just don't want you to feel blindsided if you do get the plugin. Yeah? Also, rendering things that have more than 500 layers is going to be a little challenging on the memory. The Adelinda time-lapse I showed you, it was just about impossible to render without a significant amount of elbow grease. But at the same time, I am no Blender expert, so it's more than possible that I missed something. Feel free to leave the tips in the comments. And here are a few tips that would make your workflow smoother from my side. Let's take a look at a few tips, starting with a few rendering tips that would make your life easier. If you're using cycles, you can lower the samples to around 60, and I found the end result to be crisp enough for my purposes. Another option that can speed up your renders if you're trying to make a time lapse is this persistent data option. It essentially cut my render times in half. There are a lot of features in the scene and Blender tries to synchronize them for every frame. By checking this option, you tell Blender to keep the data in memory between frames. This would definitely massively improve render times, but it would cost a lot of GPU memory. So you'd have to see what kind of resources you have available. I did this with my Sanjay Mortimer time lapse and I was averaging about 20 to 30 seconds for a frame. Now let's get to the add-on itself. You should keep most of the features except for the external perimeter in the viewport invisible. This would make Blender more responsive. If you are still facing issues though, you can go down to the extruder error section, pick 50 to 60% for selection probability and hit make selection, and then hit H. It would hide a big chunk of the layers. You can bring them back by hitting Alt plus H. There is also this experimental option for Meshify. This would take everything and turn all the features into mesh. Currently they are curves. It is painfully slow and there is no UI reporting. Also, you'd have to make sure all the features are checked before you click Meshify. This does help a lot with render times, but it still needs a lot of improvements. The last tip deals with slicing the model in PrusaSlicer. The biggest slowdown comes from very high resolution G-code. You can easily tackle that by increasing the value for this option, G-code resolution. For the Sanjay Mortimer time lapse, I kept it at around 0.1 and I think the resulting evenness only added to the overall 3D printed look and made my workflow and renders much faster. There are so many additions that I would be making to the plugin. Some I term trivial, those are the things that would require some time, things that I have figured out just haven't implemented yet. Some others are non-trivial, that would require a good amount of elbow grease. Amongst the trivial things though, the top two tasks would be Cura support and VAS mode support. Some others are producing convincing stringing and possibly better seam management. Now on the non-trivial things, increasing time efficiency is my top priority. As I already stated, the time complexity of the script is exponential as the number of layers increases. It really shouldn't be, but for some reason it is. So I'd figure out why that is and fix it. I might have to take a deeper look at how Blender processes things, but I'm sure I'd be able to figure it out. Increasing memory efficiency is my other top priority. As I said earlier, there is a lot of geometry. I'd have to figure out ways to make things more memory efficient. I might have to dig a little bit deeper into how Blender produces this bevel geometry, and I might have to redo it from scratch, but I would. Another major thing is possibly a way to recreate an approximation of the original model from the GCode file. This would admittedly be a bit more challenging than anything else. There are also a lot of other big and small improvements that I would be working on in the meantime. Now, let's talk about the release. I don't make these. While I was editing the video, my application was fortunately accepted by the Blender market. So disregard anything I say about Etsy in the next section. The add-on would be available on Blender Market and Blender Market alone. Any of my patrons can still request a coupon code that would give them 100% discount on the add-on on Blender Market. But still, keep watching to find out how you can help me make this add-on open source. I don't make these things to sell them, honestly. Earlier, I made a GCode designer tool that gained some traction, and also a tool that allows you to do multi-material printing with a single material printer. I really want to give back to the community as much as I can, and I want to open source this plugin. But I am asking for a little incentive. Help me get to 3000 likes on this video and I'd make it open source, honestly. In the meantime though, if you really want a copy, you can get the beta release for $12 on my Etsy store. The link is in the description. And any of my patrons on any tier would get a copy. As of right now, my application has not been accepted by the Blender market, but as soon as it is, I would release it on the Blender market and updates would be available via Blender market. Anybody who has already purchased a copy on Etsy or is a patron would receive a coupon code for Blender market. I do realize that maybe it's a bit unfair to ask you to pay for a beta release, but it is a fully functional product and bug fixes would be quick as hell. And I really do need a little support to make it more polished. And anyway, I'm hoping you guys would share the video and I'd open source the add-on soon enough, and there would be no need for any other sort of hassle. So with that, we are at the end of yet another video. Please join us on the subreddit, share your renders with us or any other ideas or improvements. If you liked the video, you know what to do. If you didn't, that one is okay. Really need your inputs, so leave them in the comments section below. Subscribe for future content, and until next time, just keep building.